In order to prove this is a hyperbola, we have to convert it into that standard form for a hyperbola, which looks like what? How do they start out? Okay, x minus h squared Okay, now we said there's two versions, right? This is one of them. What's the other one? What changes? In a hyperbola, a always stays in the first position, right? It's the tops that flip. So it might be the y minus k first and then the x minus h. All right, how are we going to know which one we're trying to get it to look like? Look at the equation they gave us. It has a 9y squared minus a 4x squared. That tells me that the y pieces are going to be first, and then I'm subtracting the x pieces. Yes? Because this x here is negative? Okay, so I actually want y minus k and then x minus h. Okay, that's what I want to try to convert it into. Now, if it had been an x squared minus a y squared, I would have used the one we had originally. Okay. So the way you can tell that it's a hyperbola is it's going to have two squared variables, but there's going to be a minus on one of them. Okay. The technique we used was that completing the square pattern. All right, so we want to regroup this and put everything that has y's in the first position, and then anything with x's in the next position. So I'm going to have 9y squared minus 18y. I'm going to have a negative 4x squared plus 24x. And then what did we always do with that 63, that constant? Moved it to the other side because it's usually not the number I need, right? So we're going to add it over there. We okay so far? All right, now, before we can complete the square, before we can figure out what that missing term is to put in, we have to do what? Do what? Nope. We need to move this 9 and the negative 4 out of there. Yes? We need to factor out that first coefficient, okay, the coefficient of those squared terms. Because when you're completing the square, it has to be just a single y squared. Okay, so if we take out the 9 in front, we're going to have a negative 2y left. Okay, doing the same thing with the x's. We're going to pull that negative 4 out, which leaves me x squared, and then what? Yeah, watch your signs. It would be negative 6x. Yes? Okay. Now we can figure out the missing term. So we take half of this negative 2. Half of negative 2 is negative 1 squared 1. So I'm going to insert a 1 here to complete that square. But what have I really put on that side? I'd really put a 9 because that 9 is getting distributed into it. Okay? So I've really added 9 to the left side, which means I have to add 9 over here. Okay? Now I'm going to do the same thing with the x piece. I'm going to take half of negative 6, so negative 3 squared. So I'm going to add 9 over here, but what did I really put on that side? Got a negative 4 times that 9, so I've really put a negative 36 in here. So I have to combine that over on the other side as well, the negative 36. Okay, so what do we have total on the other side? 63 plus 9 is 72, and then subtract the 36. We good? All right. What do we do on the left? What do we do on the left? So we want to factor this, right? We completed the square to make it a perfect square trinomial. So we're going to factor it into that. Okay? So y squared minus 2y plus 1 is going to factor down to y minus 1 squared. Okay? Same thing on the other piece. What do we get? Okay? And we said this all equals a 36. And our last step then would be to do what? Yeah. Divide that 36 out of everything. So we're going to have y minus 1 squared divided by 4 minus x minus 3 squared divided by 9, and it equals the 1 that we need on the right side. So did we get this to look like a regular hyperbola? Okay. What else did they ask for? We've proved that it's a hyperbola. Now they're saying figure out vertices, foci, and asymptotes. Okay. All right. So to do that, let's start with center. What's our center going to be? Look at it carefully. What's our center? 3, 1. Good. X first, y second. So let's plot 3, 1. Okay, that's going to be my center. All right. Then I have to find my A's, B's, and C's. Okay, so what's my A value? How do I know it's the 4 is A squared? Because it comes first. In a hyperbola, A is always first. So A would be 2, and it's paired up with our y variable. And that means B has to be 3, and it's paired up with x. Okay, so let's go to our graph. We're going to go up and down 2, right? Y direction, 2 spaces up, 2 spaces down. And what do we label those? Vertices? Okay, so what are the vertices? What are the coordinates? Okay. Right? So we basically took our 2 here and we added and subtracted it to our y coordinate, right? Okay. Then we can go 3 in the x direction. We don't label those anything. Why do we put them in? To make our box. Okay. So let's make our box. We put in our diagonals that are called what? Asymptotes. Okay. And then how do I know if my branches are up and down or side to side? What? Yeah, they have to go through a vertex. So we would have a branch here, touching the vertex and approaching those asymptotes, and one down here. Okay? What are the foci? How do we find those? Okay, so we have to find C. And in a hyperbola, we have the relationship that C squared equals A squared plus B squared. All right, A squared was 4, B squared was 9, adding them we get 13. So C is going to be the square root of 13. Okay, square root of 13 is between what two numbers? Between 3 and 4? Okay, so let's plot those. So from my center up 3, somewhere between 3 and 4 would be a focus, and then down between 3 and 4 would be the other focus. Okay, but to get the exact coordinates of those, I'm adjusting which coordinate? The x or the y? I'm changing my y, right? From my center point, I went up and down how much? Square root of 13. So from my center point, which was 3, 1, I'm adding and subtracting the square root of 13 to my y coordinate. Okay. All right, and then the last thing they asked for was the asymptotes. Remember, asymptotes are always going to kind of look like that y equals mx plus b kind of format, right? So we need our y piece on the left. And if it's not a plain y, if there's a shift in your center from the origin, we have to include that. Okay? So going from our equation, we had a y minus 1 chunk. So we're going to have y minus 1 equals plus and minus. Why do I need the plus minus? We have two different asymptotes, right? We have one that's coming down with a negative slope. We have one that's coming up with a positive slope. Okay? So we need our slope, and then we're going to have our x piece, which from our equation was x minus 3. So all we really have to do is figure out our slope from here. How much did we rise to go from center out to this corner of my diagonal? We went up 2 and we ran 3. Okay? Questions on that? Okay. I'm going to pass out another sheet that got missed in your packet. While I'm doing that, I would like you to just read through this top paragraph. With all of the different conics that we've looked at, we've tried to give you an example of where you might see it in the real world. Okay, so for example, the parabolas. What did we have as some applications for a parabola? Okay, a headlight, right? Because any light that comes from that focus point will bounce off the edge of the parabola and shoot straight out. Okay. Microphones, they had like on the sidelines for a football game, right? Put the microphone at the focus and it'll collect all that sound. For an ellipse, what did we have as examples? The kidney stone one, right? You put a person stands at one focus and the shock waves are emitted from the other focus and they bounce off the edges of the ellipse and go and hit the kidney. Okay? So here's one that talks about where a hyperbola could be used. All right, looking at our picture, we have this light source. It's coming in and it's bouncing off a parabolic mirror at the bottom. Okay, now when it hits that mirror, where is it going to go to? Anything that comes in and hits the edge of the surface of a parabola is going to bounce back to the focus, right? Works the same way as the light coming from the focus and bouncing out. Okay, so this is going to be reflected off of this mirror at the bottom, go up to the focus of the parabola. Okay, now they have positioned a hyperbola or hyperbolic mirror here. Okay, one branch of the hyperbola. Its focus is the same as the focus of the parabola. Okay, they lined them up. So that light is going to come in, bounce off the parabola, go up and hit the hyperbola, bounce off of that. Okay, so it's coming out of there. Then they've positioned an elliptical mirror here, and they've lined up the focus for the hyperbola and the ellipse. Okay, so that's going to bounce off this one and go towards the other focus of the hyperbola, which is now the focus of the ellipse. So it's going to bounce off the ellipse and go to the other focus of the ellipse. Okay, so they've combined all three shapes, mirrors that resemble a parabola, a hyperbola, and an ellipse. And all of that light that was directed in initially is going to come out right here. Okay, so just an example of where, you know, they've combined all of these different conic shapes. Okay. All right, the last piece that we're going to look at is the sheet I just passed out to you. Okay, it has 3 different conics, but I haven't told you which one is which. So the first thing you're going to do at your tables is determine what conic it should be, and then you're going to use completing the square to get it to look like that. Okay? You don't have to find any vertices, foci, covertices, any of those details. You're just converting the equation. Okay? So how are we going to know that something is a hyperbola? Has 2 squared variables and a minus sign by one of them, right? If it has 2 squared variables but they're both pluses, they're both positive, then what? Then it's an ellipse. How do we know it's a parabola? There's only one squared term, right? So decide which one is each, which shape for each question, and then convert it using completing the square. All right, can everybody check the first one? Are you agreeing with this? Yes? Okay, I'm going to pause it again so that you can work on the second one. Make sure you ask questions as I come around. Okay, let's check your second one. Should have been an ellipse. X minus 6 quantity squared over 25 plus y minus 2 quantity squared over 100 equals 1. We okay with that one? Okay, ask if you have questions as we finish up number 3. All right, let's check our third one. Should be a parabola. We should have y minus 10 squared equaling 2 times x plus 3. Okay, just a quick review of parabolas. The vertex would be negative 310, right? In all the other shapes, that was the center, right? At HK was center, but in a vertex, we don't have a center point. So that is our vertex, negative 310. Our p-value comes from here, right? That's 4p. So p would be a half. Yes? It's a y-squared kind, which means what? It opens sideways, and since p is positive, it's going to open to the right. Yes? Okay. All right, so there's your second day's assignment, 47 to 52, 67, and 68. You have 8 questions to do.